Good day, everyone. I trust we are all good. In the previous video, we looked at solutions to question 9. In this current video, we'll be looking at solutions to question 10 of Met Paper 1, May, June of 2024. All right, let's get to it. Question 10. HEHGF is a rectangle. HE is produced S squared centimeters to N, and EH is produced S squared centimeters to P. NF produced intersect PG produced at M to form an isosceles triangle MNP with NM equals MP. D lies on MP, where MD is perpendicular to NP. NP equals 4 centimeters and MD equals 3 centimeters. Question 10.1. Show that the area of rectangle EFGH is given by A of x equals 6x squared minus 3x to the power of 4. All right. So to solve that question, let's look at the diagram. So here, we know that the whole of this length, NP, is 4 centimeters. And this is an isosceles triangle. If this is an isosceles triangle, it means that the length of MP would be equal to the length of MN. Now, they said that this line MD is perpendicular to line NP. So if this line is perpendicular, it means that the angle here is 90 degrees. So if we look at this triangle, we know that it's an isosceles triangle. It means that this angle here, angle P, will be equal to angle N. Now, the whole length of NP is 4 centimeters. And now, if you look at NE is S squared. And also, HP is S squared. So it means that the distance between DH and ED or DE would be the same, right? So that means that the distance from ND or the length of ND would be equal to the distance from D to P, that is the distance DP, right? So from this diagram and from the illustration I've made so far, it is glaring that this ND will be half of the entirety of MP. So that means that ND will be equal to DP, and that will be equal to 2. That is what I represented here. All right, so let's see some calculations. So now let's look at EH. EH, the distance from E to H. So the distance from E to H will be this distance, 2 minus S squared plus 2 minus S squared. If we simplify that, we will get a value of 4 minus S squared. So that will be the value of EH. Now, let's look for the value of angle N, right? So this, okay, 3, okay. To calculate the value of this angle N, we would see from the question, MD is 3 centimeters, right? And we know that ND, this ND is 2 centimeters. So from those data, we can calculate the angle, or we can calculate the magnitude of this angle. So if you look at this angle N, you will see that MD is opposite to angle N, and this ND, which is 2, is adjacent to angle N. So, and you know that this is a right angle triangle because this is perpendicular to this line. So it means that tan N, the tan of this angle, will be equal to 3/2, opposite over adjacent. So that will be the value of that angle N. So we can calculate the angle. So by the time you bring tan to this other side, it becomes the tan inverse of 3/2. And we can just punch that into the calculator. If you punch that into the calculator, you will have shift, then tan. Then 3/2 is 1.5. So that gives a value of 56.31 degrees. That is the value we have there. So let's see further things that we can do in order to solve that question 10.1. So now, if you look at if we extract triangle NFE, that's what we do here. We know that this angle N is 56.31, right? And we know that NE is x squared. So from there, we can calculate this B. We can calculate this B, which is FE. So here, we use the tan of this angle. So the tan of this angle will be equal to the opposite, which is FE, which is equal to B, divided by the adjacent, which is S squared. So here we can make FE the subject. So yeah, we know that this tan 56.31 will be equal to 3.2, what we have here. So we could see that FE will be equal to 3/2 S squared. So we can just simplify that. So since FE equals B, so that means that B equals FE will be equal to 1.5 X squared. Okay, so we know that area of a rectangle is length times width. So if you look at this place, we could see that here, if we extract this rectangle, EFGH, we could see that this B is 1.5 X squared, and the EH is 4 minus 2S squared. If we multiply those two together, then we would get very close to the answer. So if we multiply them, we open this bracket, we will have 1.5x squared times 4. That gives us 6x squared. Then 1.5x squared times negative 2x squared. That will give us negative 3x to the power of 4, which is what they asked us to prove here. Now, question 10.2. Calculate the maximum area of EFG. You know, I always advise my learners, whenever you see this word maximum, it means they want you to optimize. And to optimize, you must be ready to differentiate. So let's see. We have already established from question 10.1 that the area has the expression 6x squared minus 3x to the power of 4. So let's find the first derivative of that. So if we derive this equation, we have 12x minus 12x cubed. We can then set that derivative to 0, and we can factorize with x. If we factorize with x, we would see that we get three values of x there. So x could either be equal to 0, and we set the content of this bracket to 0 and solve for x. So if we solve for, okay, we are trying to solve for x for this second one. So we can see here, if we solve for x, x will be equal to plus or minus 1. And here, x equals 0. If you set 12x to 0, x will be equal to 0. So we have three roots now. We have x equal to 0, x equals -1, or x equals +1. So those are the three roots of x. Now, to calculate the maximum area, we just have to substitute each of these values into the area equation and see which one will give us the highest value. So when x equals 0, we just substitute 0 here, and we get a value of area equal to 0. Now let's look at the area when x equals 1. When x equals 1, the area would be equal to 3 centimeters squared. Let's look at the area when x equals -1. So when x equals -1, the area would also be equal to 3 centimeter cubed, which is equal to what you have here. So that means that the maximum area that that rectangle could have is 3 centimeter squared. All right, thank you so much for being with us till the end of question 10. I really appreciate your patience and your audience and your commitment to this channel. Next, we'll be looking at solutions to the final question, question 11. Till then, stay blessed.